Cole Crawford says that it's no longer a matter of if we will move to edge computing, it's a matter of when and how soon. Cole is the CEO of Vapor.io, which is utilizing colocation facilities and interconnection services in order to bring cloud-like services to the edge of the wireless network. On this episode of IT Visionaries, Cole talks about what all that means, why it makes sense to invest in the edge ecosystem, and what the future of the edge looks like. Enjoy this episode. IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform.
Welcome to another episode of IT Visionaries. I'm Ian Faison, Chief Content Officer here at mission.org, and we have in studio, I like to think he flew in just for this, but I don't know if that's true. Cole, how's it going?
As far as this show is concerned, I absolutely flew in for this. It's going great. Ian, thanks.
So excited to talk to you today about what you're building at Vapor. But first, in the edge, we're going to talk a lot about the state of the edge. This is Edge Week after all on IT Visionaries. We're talking about the edge. And before we get into all that, how did you get into technology in the first place?
Oh, this is an interesting story. And you have kind of your namesake, a guy named Ian, actually was semi-responsible.
A great man. We really are.
So I won't argue. We back in high school. So this was in the mid '90s. I was in a group of friends, more of the tech-oriented, nerdy, group than, even though I did play tennis and I was a very good tennis player. That's still not one of the cool sports. Yeah, so it wasn't basketball or football. So my friend group was, we were kind of the kids working on tech, looking at, the fun things you could do with computers. And I remember clear as day walking into a friend's house, and he had this blue screen up, and I just, out of the corner of my eye, this was Windows 95 days, right? I said, "Oh, the blue screen of death, that's not great." He's like, "No, man, this is Linux." And I was like, "What the heck is Linux?" He's like, and the backstory here is there's a little known subculture called Church of the Subgenius. You probably never heard of it. Mm-mm. Yeah, you have to look it up. And Ian Volkerdink was the kind of one of the priests of this church, and it was almost you'll have to look it up. I don't want to totally go into it, but it's a parody religion. It's not meant to be taken seriously at all, and it's directed at one group of people who I also will not mention on the show. But if you're interested in the background, it's interesting. And the philosophy of this little Church of the Subgenius was to create what's called Slack, which is just kind of goodwill and kind of peace to everybody. They called it Slack, and Ian was the creator of Slackware, which was a very early Linux distribution. Still, tons of people use Slackware today. My friend was like, "Oh no, man, this is Linux. This is Slackware. This is the future." And I got into tech through this Church of the Subgenius thing, which is crazy. I my parents always said, "You're going to be a doctor or a lawyer." And then when I discovered Linux, I was like, "No, I'm going to do this." And that's how I got into tech.
That's crazy. And I'm definitely we'll link it up to some articles on all things Subgenius. That sounds pretty interesting. Did you find that there were like things about computing or working on computers that like you enjoyed the problem? Was it that you liked building? What was it?
100%. And actually, it's part of the reason, if you know anything, kind of about my background, I'm a huge open source advocate. I've spent a lot of my early career building, Linux implementations. I ran a very successful business running Unix to Linux migrations for very large organizations. And I've always liked that aspect of tech for two reasons. Number one, I believe in the principles of open source. and there's 4 main principles, and we don't have to get into them, but I believe in the 4 main principles of using open source software. But also, I remember running Slackware, and at the time, it was a big thing for you to have a great sound card. Remember sound blasters?
No, not really.
Yeah, I'm older. But sound blasters were a card, and they worked fine in Windows, but in Linux, there was a lot of variables that went into this, like IRQ settings and different different settings and drivers that didn't even exist back then. At the end of the day, the ability to basically manufacture your own aspirin, right? The ability to take something that the guts of something great are there, and your ability to enhance or extend that to make it do exactly what you want it to do, that freedom was absolutely incredible to me. And that really drew me in, both on the creative side of this, because in open source, code is currency, but it's also art in a way. I mean, you are creating something that is uniquely yours, and that code, if it's good in a social setting, depending on the various projects that you might be working on, could live on for decades. There's a ton of code that lives in the Linux kernel today that was written a decade ago.
It's funny, we always talk about that with storytelling here, about like storytelling is code that's like written directly for your brain. That's why we pass down stories for literally thousands of years, because it like resonates. And so it's similar sort of thing. It's like the idea that you could create something that lasts for a decade, 2 decades, 100 years, something like that. Yep. It's just fascinating. And it's like, we didn't have computers yet 100 years ago. Well, I guess you could argue maybe, but the idea that people could create things today that last for 100 years, like that, those lines of codes is like ridiculously empowering. Yeah. So flash forward to today. Why did you found Vapor?
So for a number of reasons, and I was thinking about it on the Uber ride over here, and I had a lot of time to contemplate on the ride over.
It's a long ride.
It's a very safe ride. IT Visionaries, right? The theme, it harkens back for me to this movie, The Groundhog Day.
Sure.
You see Groundhog Day?
Yeah.
When he's sitting down and he's saying, maybe I'm a god. Maybe I'm not the god. And I'm in no way drawing a parallel to myself. I'm just, if you've been around long enough and people have told you basically everything about their plans, if you can contextualize, you're going to have a pretty good idea about what to do. And, visionary or not, I do think I had some pretty incredible access to a lot of data. And that's, I strategically went into open source and nonprofits, because when you are running or building a technical nonprofit, your job is basically to link people together, and create a 1 + 1 = 3 type of equation. But that means getting insights into what needs to be built for the future. So when you're running a company, and building an initiative like the Open Compute Project, like I helped build for a group of small, well, not small, very large companies like Facebook and Goldman Sachs and Intel. And you've got guys like Andy Bechtolsheim on your board of directors. You end up asking and sometimes being given roadmaps, right? Visionary roadmaps on, hey, directionally, this is where we want to go. And I had seen what was happening with Linux. I had seen what was happening, obviously as a co-founder of OpenStack, I got to help build that foundation, and we got to see that, propagate. But there were some challenges. There were some technical challenges. There were some implementation challenges, and there were some architectural challenges that I thought were going to be hard to solve for with this big data deluge. I mean, before we have sort of crystallized as a community into, calling things IoT and, post 5G, et cetera, we've always expected. I mean, I remember back in 2011 when Mark Zuckerberg came up on the Open Compute stage and showed the forecast of data that just Facebook was going to use on the wireline side. We've always forecasted exponential growth of data. I was pretty confident, having been at US West, having been at Quest as a old guard telco guy, having worked for Phil Anschutz, ultimately, not directly, but ultimately for Phil Anschutz, the guy that put fiber in the ground. I remember just thinking, man, we're going to have to get a lot better about routing. we're going to get a lot better about how this data flows, both from core to edge, but also edge to core. Today, we talk about the Internet of Things. Tomorrow, we'll talk about the Internet of Moving Things. We're already talking about it. Autonomous cars, autonomous drones, your Fitbit. My wedding ring has a little sensor in it. Won't talk about why. Yeah, it really does.
That's crazy.
And because I like real watches, but eventually, after we get to this state of sort of this post 5G world, when these single digit latency capabilities are here, we'll be talking about the Internet of Skills. I mean, there's a progression. The IoT. Earlier, we were talking about icebergs, right?
Yeah.
IoT is the tip of the iceberg for what's possible. Robotic surgery. I mean, things that sound incredibly far out from a timeline perspective are not as far as you think.
Well, and I love the Groundhog Day analogy, because I do think that, especially in tech, and a lot of things are cyclical, that you do have certain founders that have that moment where you are sitting on the pavement and you're like, do I see what's coming next? Like, I think it's a really good analogy, because, and it's funny that, I am a God, I'm not the God. But I think that is a lot of the feeling that tech founder, or just founders in general, have, where they're like, I kind of see, I imagine it to the, in Indiana Jones, when there's like the clear path in front of him and he has to take the walk, right? It's like the founder's the person taking the step and hoping they don't fall down the pit.
Yep.
But then once they walk across, then they throw the sand across it so other people can see it.
Yep.
But I feel like, back to the edge, it's like, this is one of those moments in time. You could say, like mixed reality is another one of those things.
Correct.
With, this is actually, and I heard this from someone who works at Magic Leap, where they were saying that this is the first like paradigm shifting technology that everyone knows is coming, and now we can all invest in. And I kind of feel like what you're saying is that with all of this, with IoT, with 5G, there's this path, and it's like, so then what is the edge?
Yes. And I mean, that's the question for the ages, I guess. And really, I'll tell you right now, if I had a nickel for every time that question was asked to me, I'd probably have more money than the money we've raised.
Yeah, right.
But the best way I can describe it is, okay, so you know how there's no two snowflakes that are ever the same.
Sure.
Same for the edge. When you say the edge is a snowflake, you might, it's kind of funnier, but the edge is different for everybody.
It's a zebra's stripes.
There you go.
A fingerprint.
I love it. It's a fingerprint. It's
blockchain.
An iris. It's a podcast done, right? You mentioned blockchain. There you go. Magic word. But it really is something different. If you're a company that is working on, say, a factory floor, and you need a very low latency, sub 1 millisecond capability for something on the factory floor. Like your edge, living in a cloud, could not, it physically can't be that far away, because the speed of light is not that fast. I mean, yes, it's very fast, but in fiber and silica fiber and silicon glass, it's actually only about 70% of the speed of light. It's because of refraction, right? It bounces off the walls of the silica. If you're a telco, your edge is probably the relationship between the thing that sits on the tower, the base station or the small cell that is, terminating and propagating the radio access network to your phone. That service is your edge. For Vapor, our edge is the bridge to the last mile. And that's from an infrastructure standpoint, that's an incredibly challenging task to go solve for, because it's not just brick and mortar, and it's not just trenching fiber and getting city permits and permission to go dig up a sidewalk. The reality is, and it's shocking, I know, we fundamentally as a society built two different networks. The old wireline guys built an internet backbone. They built east-west traffic, the May East and May West, which terminated in Chicago. And then the wireless guys, the Ma Bells, all of the baby bells. Think about when you started using data on your phone. The concept of data on your phone isn't actually that old. That was a 3G technology, right? That was 3G. 4G made it faster. 5G is not a consumer technology. It's definitely not aimed at being a consumer technology. It's far more an enterprise technology than it is a consumer. And we can get into that later. But and the reality is a really tough value proposition to go build that bridge to the last mile, because while there's lots of great connectivity on the wireline side, the radio access network that we've been talking about, right, how we get our cell phone signals, that bridge to the internet is not well built.
Yeah.
It just isn't. We built two different networks, and it's really been, it's not a stretch to say that it's duct tape and baling wire gluing these things together today.
Is this why my internet is so bad in Oakland, California, or down the road from, we're down the road from Facebook right now, and all of these, and Google and everybody, and there's so many pockets where there's terrible internet. How is that possible?
It depends on what you're talking about. You might check your service provider.
I hear you, but anyways, my point being that clearly we're not close if
that's correct.
You don't have high-speed internet. I can't even tell you the amount of effort we go through to get business speed internet at our studio, and it is horrific, horrible.
It's bad. It's hard. The reason it's bad is because it's really hard. Look at Google Fiber, right? Just to call out something that was a moonshot attempt. And, I don't want to say a complete abandonment, but it's definitely a retreat of a consumer focused fiber service. Yeah. When you have to go to municipalities and you've got to go, get permits and establish right of ways and deal with setbacks and easements and all of the things that a city's, all the hoops the city's going to make you jump through. The zoning and permitting of building this out is just hard. And it doesn't matter, Silicon Valley has this reputation for not giving 2 cents about how hard something is. So they'll go and do it. And then sometimes they find out, these big hyperscale companies or small companies will find out this is actually very incredibly difficult.
Oh no, we had Jonathan Reichenthal, who is the former CIO of the city of Palo Alto, on the show talking about how difficult this stuff is. Yeah. And he's if any city on planet Earth should have the most streamlined technological approach, right? Yeah. But that therein lies the rub, right? And then you talk about the idea of, and we had a whole podcast called Future Cities, so this stuff is top of mind, but one city going into another, one county going into another, one state going into another, state versus federal rights, all of those things play into this thing. Yet Austin has great fiber, and I heard it's awesome.
We've got good fiber. We've got multiple gigabit providers, but beyond the bandwidth and the speed of this whole thing, the edge is as much about latency and jitter as it is about speed. And in fact, it's not just latency, jitter. Because we built two internets, I'll give you a really good example without giving you my carrier that I'm on.
Yeah.
So I'm obviously based in Austin. A little known fact for those of you listening, there's actually only about 7 locations in the United States where you can peer with other major networks. So there's about 7 big cities that you can go to and actually do your network handoff to somebody else. Unless you have a private, route that you have agreed to go build with someone else in a specific location, there's this concept called an internet exchange, an IX. And there's, you might get corrected because somebody on the show is well, there's actually a lot more than, but it's really with real meaningful data gravity, there's about 7 locations. So my carrier, I live in Austin. There's a fiber connection that goes from Austin to St. Louis, Missouri. And then that's where I actually get registered on the network. But there's no peering. There's no IX in St. Louis, Missouri. There is, however, that in Atlanta, Georgia. So I actually get on the internet in Atlanta. But if I'm on my computer or really rather on my phone, and I want to go reach a website that might be stored, in the US West availability zone of Amazon, I'm now going to traverse the entirety of the continental United States and then that packet can be sent back to me. But I'll have literally gone halfway east, all the way west, and then halfway east again.
That's crazy.
Yeah, this is how the internet works today. This is it's not even a stretch of what the architecture looks like. That's how it looks.
That's remarkable.
It's incredibly inefficient today. And so it's not just latency and it's not just jitter, but this is what you've heard of being called backhaul.
Yeah.
The concept of traffic backhaul. So economics, everybody asks me, and I might preempt one of your future questions, but everyone asks me, and the other question, what is the edge? The other one I get all the time is, well, what's the killer app for 5G? Right? I get that question all the time. And I think it's as simple as, it's very complex, but the answer is simple, right? The solution is hard. But economics and the easy button. That's it. The post 5G edge native applications that, college kids and high school kids and entrepreneurs, that are, thinking about what are the possible, the dreams that they have and the ideas that they're cooking up to solve for, well, what could I do with single digit latency end to end? Those types of applications, those are going to come. It's predicting. Humans are terrible at predicting the future. We're really bad. Remember when Twitter launched in Austin at South by Southwest? Who would have predicted that, at the time 140 characters on a website was going to be big?
Right.
If you would have said that to me, 6 months before Twitter launched, I would have said that's a company that will never work.
Well, it's like Vine, right? It's like 7-second videos, and then it's like that goes away, and then now TikTok is like blowing up. It's like, hey, people like stuff in 7 seconds. People like a good story in a short amount of time.
100%. 100%. But those types of applications will come. And, who are we to say like what those applications are going to be and what resonates with the intended audience? But what we know of today architecturally on the internet is that if you can solve economics and you can solve for an easy button, think about what made VMware so incredibly valuable. I remember I was at Dell working in IT at the time when VMware was really kind of, hitting its stride. And remember, IBM had created virtualization in the 70s. And in Linux, you had Zen. You had a virtualization capability in the Linux kernel, but it was hard because it was Linux, and you didn't have a UI. It was much harder to program against, and even the employees that you could hire to go and program those things were more expensive than their Windows admin counterparts. But what did VMware do? They made infrastructure consolidation super simple. It was an easy button for how to take a bunch of servers that were sitting at 80% idle and make those things more efficient by creating more virtual machines on physical hardware. And it was easy to do, and it helped your dollar go further.
Yeah. And
I think we're at this inflection point in our industry where the cost of capital for a lot of companies is a lot more expensive today than it used to be, right? And let me just ask a very simple question. Are you on the same carrier from 4G to 5G? When it was 4G, or have you changed carriers?
That's great. I don't know. I don't know.
So it doesn't really matter. The question really is, do you pay more for your phone bill in 4G than you did in 3G? I pay less.
See, that's interesting.
I pay less.
Yeah.
I pay less today. And actually I pay less today inclusive of all international texting, data. I get this international capability that I pay less for that experience today than I did for 3G. I think a lot, back to your question, why did we build Vapor? What was the thesis? The ROI for the investment into building these newer networks is not going to come from you or me. It's not, at the end of the day, it's always going to come from eyeballs, but our eyeballs are chemical. And the eyeballs that we're probably solving for are electrical or mechanical, right? Some IoT eyeball. And if you're going to, improve the economics of those eyeballs and that experience, you're going to have to automate a lot more. You're going to have to create zero touch networks. You're going to have to create, abstraction layers, and you're going to have to do standard deviation testing. And we're literally going to flip the way we program. I'm seeing this now with hyperscale cloud companies. We're moving into implicit versus explicit code. So we're testing the environment and letting the code make decisions about what happens based on the physical environment. And I think that's the only way we're going to solve for this. You cannot Mechanical Turk the next version of the internet.
Yeah, totally. Do you feel like there are enough people working on the edge right now? I mean, Vapor's the world's first true edge computing company, and I want you to explain why it's the first true one. But I'm also curious, like, what is this problem something that people are focused on?
So, yes, at the end of the day, the short answer is 100% that there's a lot of people working on edge. But again, it goes back to, what is your edge? There are companies that will sell you a box. There are a lot of manufacturers that are good at manipulating atoms. Bending sheet metal isn't all that interesting to Vapor. We do have kind of a unique value proposition for the metal we've patented and designed and put out in the field. But the real value is in the software. The real value is in the service and in the software. And if you're going to make the edge work, it's not about building a box and selling that box to somebody who could put it in a parking lot or put it at the bottom of a cell phone tower. Cell phone tower real estate is great, but only if you're aggregating a lot of that, right? The way to make the economics work, there's no way to make the economics work if you've got a one-to-one relationship between one of these boxes and one cell phone tower. That's just never going to work. But if you can take a 100 of these macro cell towers and 100 or hundreds of small cell and consolidate that, because guess what? It takes wires to offer wireless.
Yeah,
right. It's not doesn't just magically float around. Like, it's all being terminated in fiber.
Maybe to extend that further, like it takes rain to make clouds or something. I don't know. There's something there.
But yeah, I mean, little known fact, your wireless signal doesn't just like manifest out of nothing. There's data that gets created, in data centers and then gets shipped out, or central offices or wherever they happen to generate. But the spectrum is that last mile delivery mechanism between, a modem in your phone, which is literally a modem. So if you think about the old dial-up days, that was a modem, right? That made the little weird sound, and that was the handshake that's happening. You have the same version. I mean, you have a modem in your phone that is terminating some speed. Remember the 56K modems, and that was fast, right? That was kind of the before like ISDN. Those were like pretty fast modems on the POTS lines. But I remember starting. My uncle bought me a Commodore 128 when I was 12. And
we have so many guests that talk about the Commodore.
Oh, I loved it. It was great. I mean, I remember programming in GOS. No one knows GOS. You got to be an old guy to know this. But I started programming when I was 12, and GOS on Commodore with enhanced 64 mode. It was great. And I had a at the time I had a 200 baud modem, 200 baud, and it was incredible to be able to dial up anything. But I think what people don't appreciate about what's happening at the edge is the pace of innovation. So are there enough people, back to your question, are there enough people working on it? There's a lot of people that are talking about it. There's a lot of people that are working on it from, what's our position in it? But why we say true edge is because we have this belief system that the edge is a combination of where you can actually run a data center and probably a neutral host shared infrastructure data center. Because guess what? If you want to fix the backhaul path that I've got from Austin to St. Louis to Atlanta to California and then back again, then you need to create more than 7 cities in the United States to do the network handoff.
Yeah, sure.
Right? So you've got to create that. But then you have to be able to create, once you go from 7 to 700, you can't just throw people at that. Again, the earlier point, it's going to be very hard to solve that with people. And today's modern data centers from the biggest companies in the world are basically throwing people at the equation. It's more people, more physical cross-connecting of cables. And, the software hasn't yet been developed until Vapor built it to really create this completely autonomous, software-defined, automated, zero-touch network with all of the connectivity that you need. So the other question that I'd have about, the other sort of viewpoint that we have is, let's say that you have infinite amount of money and you put one box at the bottom of one cell phone tower. What happens when the data center breaks? Everything just went down, right? Your entire data center is gone.
Sure.
So there's no servers now working. The HVAC system fails, or the servers fail. I'm reminded of this quote from General George S. Patton. You know Patton.
He went to my college. So.
Oh, really?
Yeah.
Ohio.
No, you went to West Point.
Oh yeah, he was West Point. That's right. Yeah, of course. But General Patton said, "Fixed fortifications are a monument to the stupidity of man."
Right.
And that, just for what we're building, that really resonates, because in data center land, what happens in these multi-million dollar, 100+ megawatt environments, you overbuild. You take an HVAC system and say, okay, well, if this goes out, what do I do? Oh, we'll just buy another HVAC system and we'll flip the switch if the first one goes out. Same with generators, same with, all of the UPS systems, everything is redundant. And so if you think about what we used to do in IT, when we had, big iron, remember the big iron, the supercomputers, the Sun 15Ks, 25Ks, the superdomes from HP, we had these big, really expensive, vertically integrated box. You called it earlier. It's cyclical, right?
Yeah.
I call it the pendulum of IT.
Sure.
It kind of goes back and forth. It was hyperconverged infrastructure back then, right? You had Solaris zones, you had all of these cool ways to break up the infrastructure, but those boxes were massively overbuilt. There was lots of power supplies in them, super inefficient boxes, but they were reliable. Right? They stayed up a lot because there was redundant everything. Well, then client server came out. Remember client server? You put a bunch of cheap Linux boxes out there and cheap hardware, and you run these in an active-active scenario, as opposed to a single box that a mainframe that just sits there and is very, very fault tolerant. So there's when we talk about resilience, which is a good way to think about availability, there's two ways to get to resiliency. You can get there through high availability, which is the Vapor approach, and it's the cloud approach, and it's the client server approach, or you can get there through fault tolerance, and that is everybody else's approach. Only Vapor is building this highly automated, highly available version of this edge, and it takes the box, but it could be any box, right? It takes the software for all of the parameters that will go into why you would move a Kubernetes instance around, and it takes a network, because you got to connect it to something. Wireless takes wires.
Yes. So what does this what does the kinetic edge look like now? And then what will it look like in the not too distant future? Are these micro data center facilities combined into one place? Are they all over? Are they, is everybody going to have one in their house? I'm joking. But what's the, pardon the pun here, what's the state of the kinetic edge?
So we built this cloud down. And I think another sort of differentiator, not that I don't want this to be a commercial by any means, but I think that the way to build the edge correctly is cloud down. The hyperscale companies got it right. Lots of data centers, right? In Amazon. Let's just take Amazon because they're the kind of 1,000-pound gorilla in the room. They've got regions, and you've got US East, US West, and you've got numbers associated with each of those. And then inside of each region, you have availability zones, right? So you can choose the AZ that you deploy into, and Microsoft has the same thing. Google has the same thing. And, I just saw Oracle today announced 20 different 20 new availability. They call them availability regions, which is really confusing. but for us, the kinetic edge in a metro, like any metro, and remember, the edge for us is that bridge to the last mile where single digit latency. So let's take your mixed reality, right? We talked about it earlier. Well, guess what? Your brain is hardwired to see about 150 degrees vertically and about 180 degrees horizontally. And at every point, at every cross section, you can see about 200 points, right? Which equates to about with some mild compression at 4K resolution. Now our eyes are chemical, so these are rough conversions. but it equates to about 10.4 gigabits per second per eye. Like that's the bandwidth that your eye kind of sees at. But there's also something else that's been hard coded in your brain, which is your eyes to your brain have a 7 millisecond hard coded limit before your inner ear will get you sick if you're looking at a mixed reality environment and it's delayed past 7 milliseconds. The best 4G LTE networks today are 32 milliseconds just for the modem. Just between the RAN, just between the radio access network and you, it's about 32 milliseconds. In 5G, that's going down to 2. 2 is great, unless I've got to go from Austin to Atlanta to California back to me.
Yeah.
That 2 turns into, 25, 30, 40, 50, sometimes north of that, depending on the route, really quickly. So Vapor has, strategically built this cloud down where a metro is the region. And inside of the metro, we will place that highly available, not necessarily, it is fault tolerant, but it's not, data center land, it's tiered, right? So you've got tier 1, tier 2, tier 3. No one really builds tier 4 anymore unless you're the government, building for World War III. But there's a lot of tier 2, a lot of tier 3 buildings still being built. The hyperscale companies kind of build tier 1 plus a little bit. But we build for some, mild amount of resiliency, like fault tolerant resiliency. But what happens when you start linking these redundant, fault tolerant, redundant systems up to each other? And now you've got, a link, a fiber link between location 1, availability zone 1, and availability zone 2 in the same market. Well, that fiber creates just an IP fabric, just an Ethernet fabric, which from a top of rack switch perspective, the thing that sits in your data center, right, in one big data center, there's no difference in latency between how you would configure one application versus the other. So, by saying true edge, we're saying bring your application as architected to this environment and it'll work. It's physically distributed, but centrally logical, right? It's logically centered. So I think that's the true edge. I think that's the kinetic edge, and it looks that way in every city. We take lots of redundant fiber out. We glue these things together through a big mesh network. So you end up with this, this mesh network on the wireline side. But that's great because there's propagation on the wireless side, right? So from the radio access networks and the base stations that sit at the towers or on top of the rooftop, or the small cell. Again, all of that has to be filtered or piped back into a termination aggregation point. And if you want to be able to do that network handoff, whether it's from a licensed spectrum or unlicensed spectrum or some private enterprise network to the internet or some other enterprise network or to a cloud, the right answer for that, and what's always been the right answer for that in the internet, is a neutral host. It's a facility that acts as the aggregator of a bunch of networks and then offers that interconnection platform. And so that's how Vapor looks, that's how we act, and that's how it will look as we kind of build out our nationwide network.
And so where are you at in terms of phases of that build? I don't know if you can share this stuff, but robust.
Coast to coast.
Wonderful.
Let's just say coast to coast, and it will be you'll see a lot of kinetic edge between here and the end of 2020. A lot. So kind of taking a step back from the technology a little bit, your company is super involved in the state of the edge. Obviously, part of the reason why we're doing Edge Week here on IT Visionaries is to talk about this. We get a lot of questions about it. It's cutting edge stuff. A lot of visionary IT leaders interested in this. But I'm curious, why invest in the ecosystem? So first off, it's a great question. And there's actually a little bit of history in how Vapor chose to raise the funds we raised. There wasn't Mark and I spent a long time sort of in a consultative approach talking with Sand Hill Road. And, from my days at Nebula to kind of doing due diligence, for companies in my role the multiple roles I had as a co-founder of OpenStack and Open Compute, et cetera, I knew that there was going to have to be a strategic. There's going to have to be, and I don't mean strategic as like, just for sake of naming a strategic, like an Intel or a Google. There needed to be a strategic investor that had a first party need for what we were going to build at some point in the near future. It had so happened that I had worked very closely. In fact, he served on the board of Open Compute, a gentleman by the name of Don Duet at Goldman Sachs. He was a partner and co-CIO at Goldman Sachs. And he got it. I mean, he understood exactly what needed to be built. He understood the problem statement, and he had an opinion about how that was going to get fixed. And he believed in our thesis. He believed in the Vapor thesis, so much so that he actually joined the company. So Don actually joined and kind of helped build a lot of what we have, today. And I knew that we would need, sort of a Goldman Sachs or somebody like that to come in and get this thing off the ground, because Silicon Valley, hardware is really hard in Silicon Valley. It's really tough to raise money for hardware.
It's funny. I talked to a founder earlier today for a different podcast that we're doing, who has a hardware startup in Minnesota, and she was just like, it was so brutal.
Yeah. Talking
to investors.
Yeah.
And it's hardware is hard. That's what everybody says.
If it was easy, it'd be called easyware.
Yeah. Easy button wear.
But I mean, hardware is really difficult. And for the value proposition, if you look at some of the biggest returns, now, obviously you can be that unicorn in software that has crazy multiples and, insane exits with even open source software. I think back to Open vSwitch, Nicira, or it was one of those examples.
But even the stuff that you see right now in the news of these companies, the one thing is like, and I forget who said this, but a famous Silicon Valley VC or somebody was like, the speed that it takes you to build a company is generally the speed in which it dies. And like, you never know where you are on the curve, right? Like, am I dying, or are we growing, or am I like about to die? But that's the same way that I think with a lot of these software companies, where it's like so easy to onboard, so easy to start, easy to swipe your credit card, so easy to switch, right? Yep. Like, and that's what a lot of them are seeing. So it's like a lot harder to switch hardware.
And therein lies the rub, right? It's harder to build. It's definitely more capital intensive to build, but it's super sticky.
Yeah.
Right. Once you've got it, it's hard to migrate off. I just had a conversation with somebody that works at Vapor. They actually use at home, they don't use Apple TV. They don't use, iTunes. They're all on Spotify. They use an iPhone. It's like, why do you use an iPhone? Not that it's a bad thing. It's just like, why do you use an iPhone versus you don't use Apple services? Like, it's what I know. I'll never switch to Android because this is the operating system I'm familiar with. And so, yeah, I mean, hardware, especially tightly integrated with software, this hyper-converged is incredibly sticky. And I would say you put that into a data center context, it's really hard. Once you've built fiber into a physical building and you're using that fiber, again, back to the zoning and permitting, it's probably even stickier.
Yeah, there also is a piece of this too, where it's like, it's because it's not for the faint-hearted and because it's longer time horizons, that also is going to keep a percentage of take like bake 100 cupcakes and each of those are, representative of VC firms. You could probably just take your arm and slide 60% of them in the trash and say like, they're not going to invest in something that has a 10-year time horizon.
100%.
Like, not going to do it.
100%. And that's exactly why we went to Goldman first. And then, I'll give you a little bit of inside baseball. There's not a lot of people that actually know this about Vapor. So this is going to be news to a lot of people.
Hey, let's break some moves here.
This will be, it's interesting. We had been in existence for probably 14 months, and we were approached by a company, international company. It would have been a pretty complex merger / acquisition. There was a reverse triangular merger with like two companies on the other side, a software company and a hardware company, and different ownerships of different. It was going to be pretty complex, but we were approached to basically, kind of exit with a modified sort of go-to-market, solving a specific version of the edge. But I mean, just almost serendipitously or fortuitously, these mails that you get from LinkedIn.
Sure.
That you almost never read.
Oh, I know.
I got one of those from a guy named Phil Kelly at Crown Castle, which is it's arguably the largest U.S. tower co, in the nation. At the time, it was 40,000 macro cells. I don't know how many thousand small cells, tons more today. And at the time, I think it was like 45 or 50,000 miles. And then they hadn't yet bought FiberNet. And so 50 became like 75, but so a lot more fiber. But at the time, Phil Kelly from Crown Castle, a publicly traded company, had just been visiting with a friend of mine who at the time was the CTO of Equinix, a big data center company. And Crown, go ahead.
Sorry, no, I was just going to say, we had Brian Lilly on the show.
Oh, you did?
Yeah.
Oh, that's funny.
Yeah.
So
he's a trip.
So this is all news, right? Like,
yeah.
So this gentleman at Equinix was meeting with Crown Castle, and Crown said, like, we have this thesis on edge. We've got the best real estate and the best fiber footprint for this. Who do you know? Oh, or do you guys want to do this? And the CEO's like we build, massive 100 megawatt, like huge buildings. Like the edge that's hard. But if you're interested, you need to go talk to this little startup in Austin.
That's crazy.
And I had worked with him on open compute, right? So I had worked with this guy, and I'd helped, bring Equinix into the open compute family. And this all goes back to the village, right? So we're taking like a long walk,
sure,
back to your village question. But he said, go talk to this little startup in Austin. Cole's the CEO. I've known him for years. Blah blah blah. So I get this email from Phil Kelly at Crown Castle that basically, and I knew who Crown was. I was, again, US West and Quest, telco guy. But your first inclination when you log into LinkedIn is always to just like go into your in-mails, thing, and just delete
all.
And I read this and I was like, oh my gosh. I responded immediately. I was like, I can host you next week. So Phil and his VP of Corp Dev, a guy named Alan Bach, who actually also now works at Vapor, they came to visit me. And I think first off, we put a hold on the other deal, right? Because this was really what I wanted to build. In fact, kind of a fun fact, in high school, I had a friend that worked at Blockbuster Video,
mm-hmm.
and in the point of sale machine, he had told me that it was like, oh man, dude, you got to check it out. It's fiber optic. It's cool. The point of sale system. So I had it in my head that, hey, if all Blockbusters were like that, that would be a great edge presence. And so my earliest conversations with Goldman Sachs were, hey, let's go raise hundreds of millions of dollars and let's go buy these or lease these Blockbuster video stores. And that could be a cool edge capability.
That's hilarious.
If they're all fiber connected, right? It's probably cheap. It's basically the Rackspace model. I don't know if you know, like Rackspace for pennies on the dollar bought the San Antonio Mall.
Oh no, I didn't know that.
And the pennies on the dollar. Graham Weston, who was a real estate guy, negotiated with the city of Austin to take this mall that was dead, right? No one was in it, and it's the Rackspace headquarters today.
That's crazy.
And they were Rackspace, one of the co-founders of OpenStack, of course.
You're talking to a guy who our company just bought a grocery store. So
nice.
Yeah.
So that was the original, and Goldman was like, yeah, we're not gonna do that, but there's enough there that we'll invest in the idea. So here's a lot less money to go prove it out. But when Phil and Alan came to Vapor's offices in Austin, I remember clear as day them leaving, and I said, I've been waiting a year and a half, almost 2 years for you to walk through this door. I mean, I've been waiting. It just felt very fortuitous, and it wasn't 6 months later that they had raised our B round. I mean, Mark and I were in the meeting with the CEO, and clear as day, he goes, Cole, this is going to be a long putt. we're not a venture capitalist company, but they made the investment, and that kind of kicked off. I think that was the first like real validation point for how. And if you ask Matt, so the next time you talk to Matt,
yeah,
if you ask Matt, why he actually ended up at Vapor, it would be Crown. I mean, Matt would tell you the same thing. And that was the first real ecosystem player, right? That was the first company that had incumbent carriers, right? Sticky hardware with towers and base stations and fiber sitting on their land. And it was the first company that we had actually gotten a hold of, or rather had gotten a hold of us and said, we have this thesis on edge. You have this thesis on edge. It lines up. Let's go build it.
Yeah.
I really do think that Crown had a lot to do with legitimizing Vapor. We had our views, right? And those views are unmodified from day one. I mean, if you go back to 2015 and you look at our very first press announcement, pre-Matt, it's Vapor unpacks, Vapor chamber for network edge, 2015. So also why we call ourselves the first true edge, 2015. But we knew that not even Crown, right? With all of the towers that they own, if you look at any one of the carriers, now depending on what carrier you look at, the shared infrastructure tower companies have taken turns buying different tower portfolios. But if you talk to a T-Mobile, Verizon, AT&T, Sprint, et cetera, they live on a combination of Crown real estate, American Tower real estate, SBA real estate, lots of tower cos. And we knew that if we were going to solve for what we needed to solve for, we needed to have conversations with a lot of people, a lot of the OTTs. So, and I'm getting a little technical on the wireless side, but OTT is like an over-the-top service offering.
Mm-hmm.
It used to be that those things lived on the network, right, with the carrier that you had. Well, now the OTTs are all living in clouds. Mm-hmm. But what cloud? Amazon, Microsoft, right? Sometimes IBM, sometimes Google, across a bunch of different companies. So we needed to have this neutral host, shared infrastructure ecosystem where people could come to a Switzerland, right? And have a conversation with a Switzerland that could facilitate what was important to them. So back to an earlier comment, kind of a solve your own pain, manufacture your own aspirin. Right?
Yeah.
Here's choose your own adventure. We're here as facilitators and we want to assist in the network builds. We don't own spectrum. We're not a hyperscale cloud company. We just offer I think a unique, differentiated, open approach to where you can terminate the edge, where you can hand off your traffic at the edge. We're here to solve that for anybody that has a first party or third party need.
Well, and I think, it's so interesting about State of the Edge is that you have a coalition of people, of companies, of partners, of which Mission is now part of it, an official media partner of State of the Edge, signed, sealed, and delivered by Matt Trefiro. Shout out to Matt for helping us join. But what's so cool about it is that it's really important to get people at the table to talk about innovation, like stuff we do at this podcast, is to be able to democratize information and get it around the world. And I think that that's part of the thing that a lot of times, I know for us in the shows that we do, is, conversations happen in the back room, or the VC's office in Silicon Valley, or they happen wherever it is. But when you're talking about, sharing reports, sharing best practices, sharing what's going on, it engages people throughout the world. I mean, like this podcast is listened to in like 130 countries. But the idea that you can just go to, stateoftheedge.com and check out the report right now, that sort of stuff is so empowering for people who want to get started in this, but have no other kind of way to.
You're absolutely right. The narrative of this, you'd asked me earlier why we chose to bring on a CMO as early as we did. In a nascent industry. I mean, this is not, I don't think the edge really is any sort of cyclical pattern, because it's really taking the best practices of what we learned when we were, building owner operated data centers, and then kind of shifting from owner operated to, cloud based. And then after cloud kind of came, hybrid cloud.
Yep.
And then that was multi-cloud. I think this all culminates in what is going to be edge. And edge is, as a term, is probably going to get overused. 100% it's going to get overused. But at some point, I remember this meme that I saw, years ago, and it had the kid from the Matrix that was holding the spoon, right? And he's like, there is no There is no spoon.
Yeah, sure.
But there is no cloud. It's just a data center that doesn't belong to you, right? It physically exists. I think the footprint that Vapor is building, it's just going to be the compute where you need it. And I think, when you go from interconnecting in 7 cities to being able to interconnect in 70 cities in the US, that's going to bring about a paradigm shift in what the art of the possible is for the applications that can be architected. And a really good example of this is, do you remember, and probably not so long ago, probably in the last 7 years, I would say, if you go back, if we rewind 7 years, do you remember how you could be in the backseat of a car or in the passenger seat, hopefully not in the driver's seat, watching a YouTube video, and then it would pause as you'd be going down the highway or through a city? It would pause and you get the little spinny thing, right? Waiting. And then it would pick up again. That was an overlay network built into your phone that was literally taking you from one radio access network to another. So what did the content companies do? The content companies pre-cached a little bit of data ahead of where you were watching. So as you moved, it just continued playing, and then it picked back up and pre-cached some more. And you can see this on the YouTube video. You see the little gray area above the red. That's actually why that was built. You cannot do that with edge to core data because it's very low latency. It's very reactive. It's not static content. It's dynamic content. It's a sensor saying I'm at whatever temperature, or I'm at whatever pressure, or I've got this value that is going to be acted on very quickly. There's no caching that data unless you can time travel.
Well, and that's like you were saying with like if you're, if it's a robotic arm doing a surgery, like there's no latency like in a robotic arm doing surgery, right?
And look, and that's a perfect example. I remember there was this, we call him the scientist, a guy named Christian von Ravenfloh. It's German.
Great name. Where are these guys all have great names?
German Deutsche Telekom guy. He's now I think he's at Telstra. There's a really good initiative run out of Carnegie Mellon called the OEC Lab and the LEL. So it's combined, Living Edge Lab. And at the time, Christian was at Deutsche Telekom, and we had one of these LEL events at Carnegie Mellon, and we had inserted latency. And all we had him do was look at the screen up here when he was actually just writing his name down here. And when we got to about 12 milliseconds, like it just became really bad. His name became like illegible. 7 seconds is a lot. I mean, it can start. You remember a few years ago, the applications that would create just a little bit of an echo in your earphones, and then you wouldn't be able to speak?
Yeah, totally. Yep.
Latency can do crazy things to the human brain.
I mean, pretty much Zoom was built off of like figuring this out, right? I mean, that's like half of the whole thing.
100%. I remember being at an event where somebody from the Singularity University was giving a keynote, and he was talking about robotic surgery, and he was asking a pretty varied group in the audience of people that probably somewhere in the 60s all the way down to millennials and maybe slightly younger. And he said, how many of you today would choose to have a surgery by a robot versus a human? And when he said, if you choose a human, like raise your hand, and almost 100% of the older guys and girls raised their hand. They'd rather have the human do it. And then, as the audience became younger, right, just in terms of their age, more hands went up for the robot. And he's like, for those that chose the robot, your odds of surviving that surgery just went up tenfold.
Yeah.
Right. Robots don't have jitter, right? They don't have shakes in their hands.
They didn't have too much coffee in the morning.
They don't drink. They didn't get into a fight with their spouse the night before. They're not depressed. They don't have anxiety.
Yeah.
But if so as we get better about, artificial intelligence, and as we're, and this is what I was talking to you earlier about, the Internet of Skills. Yeah. Right. As we start applying AI to a robot that's performed 1 million surgeries, they're going to be as good as the best surgeons on the planet.
Of course.
Right.
Yeah.
And, but from a precision standpoint, they're going to be better. So they're going to know what to look for. They're going to be able to use those standard deviation conditions for what thing to do next, but it's going to have to be super low latency. And, a lot of this will be augmented a bit by humans But again, you don't want that robotic arm moving at a 7 millisecond latency, because now you're tearing into good flesh, right?
Yeah.
And potentially organs that you need.
Well, it reminds me of when we did our podcast, Future Cities. One of the things that was really fascinating was this idea that to build a house in 1910 versus building a house now, it's actually slower today.
Mm-hmm.
Like, not only have we not improved in any way building a house, it's actually slower because the level of complexity isn't like 2 or 3x. It's like exponentially more complicated because of the amount of electronics and wiring and all that stuff.
Yep.
But so like, let's say you build that house from scratch, whatever, you build in all the latest gadgets and gizmos. There's very few cities in America, for example, that you're building from scratch.
Yeah.
So if you're building an infrastructure, an internet that's like just patching over patch over patch over patch, then it's like, how do you need to have things that can actually solve the problem and stop saying, well, we're just going to cache here. We're going to cache data and then we're going to play it again. Like, that's not solving the root of the problem.
You 100% nailed it. And actually, this is the crux of why Vapor exists. Having been a telco guy, kind of growing up in a central office, right, which is where you kind of terminate a bunch of telco gear with, NEBS compliance and negative 48 volt power distribution, which data centers don't really use, like hyperscale cloud data centers. The standard is still to use 480 volt 3-phase power. Like, that's it's redundant, it can be efficient, you can transform it pretty easily. A bunch of UPSs support it, but the brownfield retrofit of a central office versus a greenfield deployment, even if you just have to move the fiber, right, just to like build the building. And I would say it's true for houses the same way it's probably true for edge data centers. Prefabrication is the better way to go.
Yeah, that's what. So the whole podcast was sponsored by Katera, but so we talked a lot about prefab.
Yeah.
And like, yeah, it's like a no-brainer, right?
It's a no-brainer.
Right? Yeah, it's of course you would build it that way. Like, if you were to just conceptually build something from scratch, like, why would you not, reduce waste, maximize effectiveness, just like you would do a silicon chip? That's why one of the guys came from semiconductors. Because he was like, hey, let's build houses like semiconductors or, units. But yeah, no, I totally agree. Okay, so last question before we get into lightning round. What does all this mean for CIOs and CTOs? Like, is this coming to a theater near you? Is this coming to a theater near you in 2 years? Does this matter right now? How should they think about this? It's
a great question. You'd made a comment earlier that I archived, and now my recall is a little slow, but you had made a comment around being at the dinner table, right? You had made that comment. And a friend of mine in London likes to say, if you're not at the dinner table, then you're on the dinner table.
Yeah, that's good.
And it was back to the state of the edge. The only thing better than being invited to dinner is having set the table, which I feel like state of the edge does. And there's no core group that does that, right? We ask anybody to come and help us. So there, infinite number of cooks in the kitchen, if you will. Sure. Right. Yeah. We're
sous chefs.
100% that anybody can help us.
Food trucks.
Anyone. If you are, and this is, again, it goes back to pace of innovation. The applications that are going to solve for why you would invest in building out edge resources in a post 5G world, even a 4G LTE wireless to wireline world. If you believe in the thesis, or if you believe in the value of the edge the way we do, and the value proposition of the edge the way we do, easy button, economics, etc., the way to future-proof that is to start building the infrastructure today.
Yeah.
Right? You don't put cars on a highway that isn't yet built. But you got to build the highway, right? That's just the reality. Like you need to pave it, and you need to flatten it, and it needs to be built. And then, people can start moving their cars, which is traffic, right? We're just talking about,
it's like the Southwest model, right? It's like you build point to point, right?
Hub spoke, right?
Yeah. Totally.
It's 100%. And, to the CIO, to the CTO that isn't taking this seriously today, that greenfield versus brownfield conversation we just had, you don't want to be leapfrogged. You don't want someone to come in and architect net new and you're having to play catch up, not just because you invested in an architecture paradigm that was sort of one generation back. So you've already spent money to do it the wrong way. Now you got to reinvest to do it the right way. And from a timing perspective, you're going to play catch up. I think that's why CIOs and CTOs should be paying attention to the edge. This is not, in 2015, it could have been an if, right? When we launched the company, there was back in 2015, there was well, maybe you're right. I don't think the if is no longer a factor. I don't think everyone says, well, if edge is a thing. I think edge has become a thing. I think there's lots of investment into it. And I wouldn't even say that when is really a thing. It's just a how soon. Mm-hmm. It's soon. And I believe that if you're not at the dinner table, you're on the dinner table.
And so everyone should definitely check out stateoftheedge.com to get the most recent report, which will be out now. And we will be promoting as a good friend of an official media partner. All right, let's get into some lightning round questions. These questions are fast and easy, just like the Salesforce platform. You can go to salesforce.com/employee experience to learn more about employee experience on the world's #1 CRM, that is Salesforce. We love platform. Check them out. They're the best. And they bring IT Visionaries content to you twice a week for free. It's great. Cole, lightning round.
Ready.
Are you ready?
Ready.
Number 1, what is your favorite thing to cook or eat? Speaking so much at dinner tables.
Mexican food.
Do you have a favorite book or podcast that you've read or listened to recently?
The Wizards Who Stay Up Late.
Ooh, what's the pitch on that? That sounds pretty good.
The Invention of the Internet. Great book.
I got to check it out. It'll be homework for me. What do you do for fun?
I skydive.
Really?
Yeah. It's actually where Vapor came from.
Oh.
In part.
That's pretty fun. I did it 5 times during my time in the Army, and I then gave up jumping out of a
thousands of times.
Perfectly good plane.
That's funny.
5 was just about enough for me. Favorite vacation spot?
Costa Rica.
What is your best advice for a first-time CEO?
Stay the course. You have a vision. It's your vision. Execute your vision.
What question do you never get asked that you wish you were asked more often?
That I never get asked that I wish I got asked. Where did you get the name for Vapor.io?
Yeah, where did you get the name? I should ask that.
See? I got the name. It's so kind of a double answer. 1, what are clouds made out of?
Vapor.
2, at the beginning of our journey towards the edge, there was a kind of an initiative, a little bit tongue in cheek, but it was called fog computing.
Sure.
And I was like, okay, what is fog made up of? Yeah, vapor.
I love it. This has been awesome. Thanks so much. Everybody should check out vapor.io if you haven't already. Download State of the Edge. I highly recommend it. It's a great read, and lots of smart people put a lot of thought into that. Any final thoughts?
Ian, you've been great. This has been an absolute pleasure. Appreciate the time.
Thanks so much.
IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform.